Let's go. Make sure you put your phones away. I cannot compete with your phone. All right. Trim mean. Let's highlight it so we can, we know we covered it. And as you can probably guess, when you hear the word trimmed, you're thinking of removing or cutting off, right? That's exactly what's going to happen in this section. So we kind of started to explore it when we talked about outliers, right? Like what would happen if we were to remove outliers. 29. However, okay, just remember, there was a time where we only removed the outlier, right? We were exploring that, but we need to be fair to the data set. So we're going to trim on both ends, okay? Cool. So I will say, I will do that later. I won't add it just yet. So we calculated V median mode, and they were quite different. These calculations could be skewed, distorted by the distribution of data. So let's highlight that part. Calculation 29. Calculations could be skewed. Have you heard of that word skewed before? Skewed, it could be altered, thrown off, yeah, distorted, or by the distribution of data. So for example, let's say I found the average income of this classroom and I included myself in it. Would it be smart to do that? No, not fair. It would be skewed, right? Because I make big bucks, right? I wish. If there is a number that is quite different from the others in the list, this number is an outlier. Should we highlight that? I will use the same I used for this. If there's a number that is quite different than the number list, this number is an outlier. As discussed in section 1.3, an outlier, there it is one more time, outlier is significantly different from the general trend. It sticks out. An outlier can have a considerable effect. Okay? Let's use this highlighter. Outlier can have a considerable effect on the arithmetic mean. So now, guys, I'm going to start referring to the mean we've been calculating. I'm going to use arithmetic mean, AM. Let's write that down just so you're not wondering, why is he using AM? Is it because it's in the morning? No, it's because I'm referring to arithmetic mean. What am I going to use for trim mean, you think? PM? Oh, okay. AM, PM, right? TM, AM. So we're going to make a distinction. They are going to be different, guys. When you perform a trim mean, it's going to be different because you're going to remove the outliers, okay? To account for this, so to account for the outliers, trim mean may be more representative of the measures of central tendency. When there are outliers, a trimmed mean is found. Here it is. I'm going to use orange. When there are outliers, a trimmed mean is found by omitting an equal number of values on the upper and lower ends of the data set. That should have a different color altogether. Right? So, and maybe let's put some arrows here. Read this. Okay. Yeah. Why would we want to perform a trimmed mean? Right? It's basically to avoid bias or skewing, right? So let's say let's say this is an Olympic. These are judges in an Olympic performance, and they're all scoring the athlete in question. And so let's say you are a Canadian athlete, and there's an American judge in there. And the American judge is like, whatever, Canadian, you're going to get a 2 from me, right? That's skewing it, right? It's actually saying this is not personal. So in this case, to remove that bias against the Canadian athlete from an American judge, I'm not saying Americans don't like Canadians. I'm just maybe using a little bit of a stereotype. We love each other at the end of the day, right? We're the biggest trading partners. But anyways, to remove that, we would remove the 2 because it's an outlier. Which other one would we remove? We would also remove the 10 in this case. You would remove because you want to deal with this, you go ka-chink. You also have to remove the highest, ka-chink, right? Have you ever looked at the scores on an Olympic Games, like diving or anything? If you look at the bottom of the screen, you will see some scores crossed off. I don't know if you've ever noticed that. The highest and the lowest is crossed to remove bias. So then that's like a more accurate score. Okay. So if there's a judge that doesn't like you in the mix, or a judge that's like, I really like you, I'm going to give you a 10, those discrepancies are removed. That's more accurate. Okay. And I'm not gonna bother you too much with, because it's saying the same thing, but trimmed mean is a central tendency measure. It's also a MCT, by the way, that cuts down the smallest and the highest values before applying the standard averaging for greater accuracy. I cannot highlight this, but greater accuracy, can we do something like that? I don't know. I'll try it. A trimmed mean has a greater accuracy. Okay. So we remove, essentially we cut our values. Okay, guys, so if you did an arithmetic mean, you would just go add them all up. How many values are here, by the way? 2, 4, 6, 8, 10, right? There are 10. If you remove these, you're down to 8. Okay. Can I just say something? Sometimes you're going to have two outliers on the upper end. Let's say there's two huge numbers here. To remove 2, if you want to remove both of those, you're also going to have to go down to the lowest and remove 2 lowest ones. It's always like for every one at the top you remove, you have to also remove one at the bottom. You can't just go, oh, let's get rid of 2 at the top and just 1 at the bottom. It doesn't work that way. Not with trimmed mean, not by definition, okay? Examples where trimmed mean may be more representative. It's in the Olympics. I just talked about that. Production levels at a company. So for example, let's say you had an off day. I remember I worked at KitchenCraft and one of the big transformers blew. The whole plant was out of power for the whole day. And so we were all sitting outside. Some people were throwing footballs and stuff. It was just bizarre. But that you wouldn't want to include in your like production, like how many kitchen cabinets do we make a day? You wouldn't want to include that necessarily. Okay, so let's keep going here. Come with me. Page 30. Grab your calculators real quick. We're going to figure out the mean and the median. Highlight this. How trimming data affects the MCTs. And you might think mode, what's up with mode? Mode I will not talk about in this case. I just want to compare the mean and the median every time. Okay, so let's include all of our values. Let's find our mean and our median. Let's do that real quick. 0.7, 0.9. Or are you just going to trust me on this one? I think you can trust me. I haven't been making mistakes today, so I'm on a good streak here. Okay, 41.7. If you add this up, you get 41.7 divided by 10, which is 4.17. We'll just go units. Make sure you write this down, right? This is page 30. What's the median here? Is this even? 2, 4? Yeah, it is even. 10, right? Even. So we got to go 10 divided by 2. That means that I'm going to have to go 5th and 6th, right? And divide that by 2. So let's go. This is already a range, by the way. 1, 2, 3, 4, 5, and 6. So let's figure that out. Median is 2.3 plus 3.1 divided by 2. That ends up being 2.7 units. There you go. So that's that. Next. I think I'm going to ask you to do this. But let's say determine the mean and the median of the set below after trimming the data as shown. So we're trimming, so go like this, cross this off and cross this off. So we're gonna, which one of these two would you consider the outlier? Janelle said it nice and loud. I could hear it. Could you hear? Which one is your outlier? 0.7 is close to 0.9, but if you look at 4.4 and 20, there's a big gap, right? So this is actually the outlier. Make sure you make a note of that. This is the outlier. And it's because you want to remove the outlier, this one, you go, okay, ka-chink, I don't want that. You must, by definition, take out the lowest as well. But this is not an outlier. I'll say not an outlier. But you have to cut from both ends. So I want you to find the mean and the median of this resulting set. Go ahead. You can do it. What will be the mean and the median? I just want to, and then do it also for the set underneath it. Go ahead. So for the next set, cut both of these, cut both of those. What will be your mean and the median? It's an important point that I'm trying to make here. So figure that out. However you do it, it's up to you. I don't need you. I will do the work quietly here. Is the median the same? Because now it's 8 values remaining, right? So 8 divided by 2 is the fourth and the fifth. So 1, 2, 3, 4, 5. It's still 2.3 and 3.1. That is 2.7 units. And one more. Did you notice what I did here, guys? What did I do? Instead of adding the 8 that remain, I took my previous mean and I subtracted the 2 values that I'm getting rid of, and now I'm down to 8 values. So I got to 2.6. Let's just finish this page and that'll be it for today, okay? I just wanted to introduce it. Next, for this one, why do I do TM, guys? Trimmed mean, right? It's still sometimes just called the mean, but we should know, oh, we're removing. Okay, this is actually a trimmed mean that I'm performing, which is more accurate. Next, trimmed mean, this one down here. I'm just going to say that it adds up to 15.5 divided by 6, and that is 2.58 units. Any guesses what the median is going to be? It's still 2.7 because it's still going to be these two here, right? The average between these two. So 2.3 and 3.1 stay the same. Median is still 2.7 units. Okay. Okay. Let's look at this now. I want you to grab a highlighter and just say, look at all the modes here. Any changes? No change. So at the bottom of this page, at the bottom it says, just say no change. Nice and big. No change to the median. Can you see it down there? What about the mode? That's mean. I meant to say. What happened to it from the very beginning? It went from 4.17 to 2.6. Did it change a whole lot from 2.6 to the next one? It didn't change a whole lot. Why is that? Because when you went from this set, the 8, to the 6, there wasn't, the outlier had already been removed. Like the big change only happens once you remove the outlier, right? From year to year. But there isn't such a significant change anymore because after that, you're not really removing any outliers. So I would say just put down here mean is the most affected. And you put down in brackets the outliers, right? The outliers are the reason for that. Before you go, you're still lucky for me to have this prop, okay? Because this, I've been having this for, I don't know, been teaching for 13 years. So every year this is getting shorter. So maybe by the time I retire, this is gone. Okay, this tape. So I always want to show my students, I try at least. This is a piece of tape, and that's supposed to be my median, right? Because technically you fold the data along that and you have an equal amount on either side of the mean. So if you take scissors and if you trim off the same amount on each end, I'm just going to do a little slice so it lasts till I retire, okay? Right? It doesn't, like if you think about it, the middle hasn't changed. It hasn't moved because you're removing the same amount from either end. Okay, so the trimmed mean will not affect your median, really. It will only affect the mean, especially if there's an outlier. Let's give the outlier a color here. Okay, this is what affected, like when we included it here, you had 4.17. When you removed it, it dropped significantly. Which one do you think is more accurate, really, when you look at data set, the regular arithmetic mean or the trimmed mean? Your answer should always be, by the way, yeah, the trimmed mean. You should always say the trimmed mean. And why? Because it omits outliers. Okay, we'll talk more on Monday. For homework, I will post it